All right, I'll give people about 1 or 2 more minutes to arrive since we're waiting for some people from the other class as well. And then we'll get started here. All right, so the goal tonight is to cover aggregation, just a little bit of review for my students who have come to the lab sessions we did earlier in the week. And for those who weren't able to make it, I posted a recording in Blackboard, and for those of you that are in Andy Catlin's class, I will be happy to post the recording of that lab and the materials for that lab in his class as well. So we're going to look at just a few examples tonight of aggregation, and then we're going to take a few examples of MapReduce as well. And then we'll talk just a little bit conceptually about each of those as we go. So the data that I'm going to be working with are fictional data, just a small data set, and in particular what they look like is this. And what we have here are a set of courses in each of 4 departments, and for each course we have a section number and an enrollment for that course. And so we're going to look at just some different ways that we can aggregate data from this data set. And I'll post this data set as well so that you guys can play with this as well. All right, so I already have MongoDB running. What I need to do is bring in that data set. So Mongo import should be becoming pretty comfortable for you guys at this point. So I'm going to bring it into a database that I'll call Meetup for tonight. And the file I'm going to bring in is stored on my local machine. So adjust your path accordingly. And for those who haven't seen it before, Mongo import will use the file name by default unless you tell it to use a different collection name for the data. And I really don't want to have a collection name that long that says enrollment sample data, so I'm going to say use a collection of, we'll call it courses. Enrollment. I need to tell it the type of file that I'm bringing in, and of course that it has a header line. And it's brought in all 16 rows of that sample data file. Okay, so we'll enter the MongoDB shell here, and let's get started. So I want to cover a few questions from that data set. The very first thing I do want to show you, though, is how to count the number of courses. And I want to talk a little bit about this because we're going to look at 2 different ways to do it, just to show you some of the built-in capabilities in MongoDB. The first thing I might do if I want to count the number of courses, of course, there's a built-in function for that, to count the number of documents in a collection. and it's just this db.enrollment.count function. And so there are 16 different courses. And if we wanted to see them, of course we would use dbenrollment.find, and we can see there all 16 of the courses came in as that. And that's an example of an aggregation function that's built into MongoDB to make your life just a little bit easier. Let's take a look, though, at how aggregation generally works in MongoDB. And to do that, I'm going to go to the aggregation help document for MongoDB here and just take a look. These help documents are actually pretty good for MongoDB. And what we want to look at is the aggregation pipeline here. The idea of aggregation in MongoDB is very simple. It's a two-step process. The first step is to match the documents that you're interested in. So in our case, we might say we want to perform an aggregation, but we only want to perform it on the physics department. And so the match stage would say, just choose documents where the department is physics. The second stage then is where we perform the calculation. So we've got the match stage, and then we've got the group stage. And the group stage is where we perform a calculation. So for instance, we might perform a calculation that's a sum. You can see the example in their help file here is a sum. But we'll also be able to do things like averages and so on. So that's the basic idea of an aggregation. It's just a two-step process. The db.collection.count function has that built in for you, where you just tell it the collection and tell it to count the documents. But the other way to do it, if you wish to do it by hand, is to do this. So here's the code that will create the same result. It's db.enrollment.aggregate. So anytime you want to run an aggregation, you use the .aggregate method. And then I'm not going to use a match stage here because I want to include all departments. But if I wanted to just count for a particular department, I would use the match stage. So here I'm going to just use a group stage. So you can see I've got $group. And I'm going to aggregate across all of the documents. And this first piece here is going to say, what do you want to use for your ID label in the result? And I'm just going to say, just use an ID of _ID so that it's standard. You can specify more complicated IDs here, and we'll see an example of that in just a minute. But for now, we're just going to say, just call the ID ID. And then what I'm going to output here is a count. So I'll call it count. And then I just want to say, as it iterates through each document, I want to add up a value for each document. And because I'm doing a count, I'm just going to add a 1 for each document. So if there were 382 documents, it would iterate through all 382. For each of them, it would add a 1. And at the end, it would have a total of 382. So this is the fancy way to implement the exact same thing we just did using the db.enrollment.count function. And we'll see here we get a result that says the count is 16. So that's one very simple aggregation. Let's ask another question. Let's say, okay, that's all well and good. It's nice to know how many courses there are, but I want to know how many courses there are by each department. And so that's a little bit more complicated question. Here, we're going to start the same way as before. We're working in our enrollment collection, and we're going to do an aggregate. All right. Rule number 1 when presenting, when your fingers get crazy with typing, always have the code written ahead of time. So I'm going to copy it over from where I have it saved. Okay, so we're going to use an aggregate statement. Again, I'm not going to worry about matching. But now for my grouping, what I'm going to do is say make the ID based on the individual departments. And so as it iterates through the document, through all the documents, it's going to create a separate result for each department value that it finds. And then again, for each of those, it's going to say create this result called count and add a bunch of 1s for each class in each department. And when I run this, the output that I get, now we can see the ID is actually which department it comes from, and we get a count for that department. And each department here has 4 classes. Let's see. So Paul is asking why the $sign. If we didn't use the $sign, I'm assuming you mean in department here. Is that right, Paul? Okay. If we didn't use the $sign, what it would do is just create an ID of department, and that would be the label that it used, and it wouldn't iterate through all the different departments and separate the results out. Of course, if you're really curious why it's doing something, one way to find out is just to try it. So let's see what would happen if I got rid of the $sign and I ran the same line of code. So what I'm expecting now is I'll get a single result where it tells me how many total courses there are, but just like we had ID equals ID up here, it's just going to replace what I highlighted with department, and that's going to be the only difference. And you can sure enough see that's what happens. So the $sign tells it not to use just a character string that I've specified, but to actually iterate through the different values in that field in the collection. So that's what the $sign accomplishes. Okay, so let's move on. That's all well and good. We know how many courses there are by department. Now let's ask how many people are enrolled in courses just in the math department. So what I want to do is know, I'm going to aggregate, I'm going to add up the number of students who are enrolled in courses in the math department. So this is going to be a 2-stage aggregation. So here's the first stage. I need to specify my match. So again, it's going to be db.enrollment.aggregate, and now I'm going to use a match stage, and what I'm going to say is match so that the department is always math. So it'll ignore all of the documents where the department is not math. One thing to be aware of, as you were doing the quiz last week, you may have discovered this. You got to be careful when you do these matches to make sure you're taking into account what happens if a document doesn't have a department field. So I'll leave that as an exercise for you guys to think about how those things affect your results. But all of these documents do have a department field, so that won't be an issue here. The second stage of the aggregation here then will be to specify a grouping. So the first stage is the match, and here's the second stage. So we're going to group. My ID is going to be based on the course now. So within the math department, there are several different courses, and it's going to say, for each course, what's the total enrollment? And now here, because I'm not just counting the number of documents, I'm going to tell it, take a sum, but instead of adding up a bunch of ones, add up the enrollment values for the courses. And so it'll actually count how many students are in each of the courses, and it'll group them so that it adds all of the courses, with the same course number together. And so when we do this, we see Math 200, the total enrollment is 40. And if we go back up to the raw data, we'll see there were actually 2 sections of that here. The first one had 0 and the second one had 40. And then Math 110 and Math 100 just had 1 section each, so it just adds those together. But that's an example of using both a match stage and a group stage. And so if we wanted to do a different department, we would just replace math with say physics, and it would output the total enrollment for the physics classes. And in physics, you'll see there were 3 sections of 101, so it added up all 3 of those together to get 85. So this is just basic aggregation. As I said, we do have a lab that works through a little bit more complicated examples, and that'll be available to you tonight. But let's move on. Let's talk a little bit about MapReduce. So MapReduce is a little bit more complicated. There are times where MapReduce gives you some flexibility that the aggregation pipeline doesn't give you. And so one of the natural questions students might ask is, why do we need both? And that's the answer. The reason you might prefer the aggregation pipeline is that it tends to run faster on smaller data sets in particular. But MapReduce tends to give you speed advantages in distributed setups where you have multiple clusters. So it's worth knowing about both. And depending on your environment, your data set size, it's worth being able to know which one might be faster. Okay, so let's do a few different calculations using MapReduce. And this is a little bit more complicated. Let me go back again to the help file for aggregation here. By the way, if you're trying to figure out how to get to the MongoDB help file for aggregation, MongoDB aggregation turns it up immediately if you search for that. And MapReduce is explained within the aggregation section. So here you've got a little bit more complicated pipeline. You can specify a query, which we're not going to work with tonight. We're going to keep it simpler than that. But that's very similar to the match stage in aggregation, where you say, okay, I only want to include certain documents. So, if we wanted to perform MapReduce on just the math department, we would use a query statement for that. And then once you've got your set of documents identified, the second column, then you need to map, and we'll take a look at what that does. But basically, what you're doing is as you iterate through the documents, is you're going to do what we call emit, E-M-I-T, and you're going to emit a key value pair. That's the idea here. And so for courses, you might say the key is the course number and the value is the enrollment. That would be an example of emitting a key value pair. Once you do that, then the next step is to do a reduce stage. And when we reduce, that's where we actually perform our aggregation in MapReduce. So we might emit a bunch of different course key value pairs, and then in the reduce stage we combine them back together and say, okay, we want, for instance, the total enrollment for each course number. And so the map stage would list, for instance, all of the sections of Math 200 as a key value pair, and the reduce stage would combine them together, and if we wanted a sum, we would tell it to do a sum. And we'll see an example of that in just a minute. And then there is one more step at the end of this that you can use called a finalize, and we'll see an example of that. That's, for instance, where we might do an average. So MapReduce is a little bit limited in how it does things. If you have data stored in 3 different locations on 3 different machines, it's not that easy to get an average for an entire data set, right? You want to pass most of the computational effort to those individual machines, but you can't take an average across 3 machines by just computing 3 individual averages and then combining them very simply. That's just not going to work, right? You don't know what the data set size is on each machine. It's much more complicated than just saying take 3 averages and merge them together in a simple way. So we'll see how we handle that here in just a bit. So let's take a look at another example. Let me clear the screen here just to get rid of some clutter. And let's take a look at a first example using MapReduce. And what we'll do is what we did before. We'll calculate the total enrollment by department. So we should get the same result that we got using the aggregation framework. But what I'm going to do, it's going to take me several steps. So I need to define functions. And again, this is all JavaScript syntax, but you should be able to mimic what we write when you're doing your homework. You just change the appropriate keywords for the data set that you're using. But the first function I'm going to create is going to be the map function. So here we go. I'm creating map1 will be my first mapping function. So we're going to do 3 different examples. So we'll have map1, map2, and map3. And for the first one, it's going to be a very simple one, where all I'm going to do is say emit the key value pair for each document, where you say the department and the enrollment. So for each class, it's going to say which department and how many students are enrolled. So we're going to get 16 of those because we have 16 documents. So we'll get 16 key value pairs. So this is going to be my first function. And if you create a function and then you type a bunch of other code and you want to see what the function is, you can just type map1 without parentheses, and it'll actually show you the code for the function. So that's a useful thing to be able to do rather than have to scroll way back up. The second function I'll create will be the reduce function. So here's my reduce function. And what it's going to do is it's going to take as its input the key value pair for each of the documents that we iterated through before. So you'll get the key will be the department, the value will be the enrollment value that came out of it for each course. And I'm giving these names I want. You could use whatever name you want for that pair of parameters here in the function, as long as they're legal names within JavaScript. It's good to give them meaningful names, and in particular I like to use key on the front of the first one to remind me that that's the key, and values on the front of the second one to remind me that that's the values. And then what we're going to return from this function is going to be an array sum of those values for the enrollments from each class. So this will be my reduce function. And again, if I wanted to take a look at it to make sure it went in correctly, I could just type its name and then hit enter. Alright, so those are the two functions I need for this. I'm going to use a map and a reduce function. I'm not actually going to worry about a finalize function for this because we don't need it. We'll see why we need it in the next example. So what I'm going to do now is actually call these functions in the collection that I'm working in. So the way we do that is we say db.enrollment.MapReduce, and notice that that's a capital R there in reduce. And then we tell it what the map function is, we tell it what the reduce function is, and then we tell it where do you want the output. And so this is going to put my output of this MapReduce in the MapReduced1 collection. So it's going to create a new collection, and it's going to put the output there. And so it gives me some results here. In particular, you'll notice that the output had 4 documents. And so now if I want to see what that output actually looks like, I can do db.MapReduced1, since that's the collection I put it in, and then .find. And we can see the total enrollment now by department. And we could have given this a different name besides value, but you know that's I guess that's aesthetics that I'll let you guys fuss with if you need to. So that's a very simple example of MapReduce. So let's take a look at a slightly more complicated case. Let's suppose next we want to know what's the average enrollment by department. So average enrollment per course by department. So we're going to need some new functions here. So here will be my first function. I'll call it map2, and it's a function. And notice here the map2 function doesn't have any input specified. So it's going to just run it on all of the documents that we tell it to run it on. So in our case, we're going to put it on the entire collection. So you don't have any inputs for this function. You don't have any parameters that you specify. What we're going to do now, though, is a little bit more complicated. We're going to create an object called value, and it's going to have multiple pieces. So before, the key value pair that we emitted was just department and enrollment, and they were individual atomic pieces. Here, the value that we emit is going to have, it's going to be an array. It's going to have 2 items in it. It's going to have a count, and for each document, since we're just counting how many classes are in the document, and each document is 1 class, we'll just say count equals 1. And then we'll also record the enrollment for the course. And if you're wondering why we do this, the reason we're going to do this is because when we take the average, we're going to need to divide by how many there were. And so the count equals 1 is going to let us do that. We're going to be able to aggregate across count and say divide by what those add up to. So we create this new object called value, and it's got the 2 values for each, these 2 numbers for each course. And if you're curious, the word this here tells it to work with the current document. So we say this current document dot enrollment, and that'll put in the enrollment value for this current document. And it'll iterate across all of the documents. So then what we emit is the department for the document, and then the value that we just constructed, which has these 2 entries, count and enrollment. So that's what this function will do. For each document, it'll output a key value pair, but in this case the value is more complex. Okay, that's the map function for this case. We also need a reduce function. So let me show you the code for our reduce function for creating this average. So here it is, and again I'm going to call it reduce2 because this is our second MapReduce example. And here again we have 2 parameters for the function. The key is a department name, so I've called it key department, And then the result, it's a combination of two different numbers, so I called it values combo, just to remind myself that I've got multiple things coming into this function in this second slot. Right? It's got a count and an enrollment for each document. Okay. What I'm going to do now is what I want to return from this function is this object which I'll call reduced val. And I used reduced val to match the documentation's example. So that's what we're going to name the output of this function. We're going to just call it reduced val. And I'm going to have this output have, again, two pieces to it. One is going to be a count, and one is going to be an enrollment. And so what we'd like to do, for instance, for the math department, count how many courses there are, and it should be 4, and then count the total enrollment in the math department. And we're going to reduce, and that'll be the output for the math department. And the reduce function will do that for each department in the data. And so we're expecting the results of this to be 4 objects, one for each of the departments. And each of those objects will have a count of the number of classes for the department and a total enrollment for the department. So the first thing I need to do is set them equal to 0. And then what we'll do is we'll iterate through all of the relevant documents. So it'll know to do this for each department. And what it'll do here is we're going to use a for loop to iterate through each of the courses in each department. So we're going to say, create this counter variable, idx, set it equal to 0, and then loop through until we get to the point where it's equal to the length of our number of documents passed. So, but JavaScript starts counting at 0, so we do less than rather than less than or equal to. Just a reminder for those who use R starts counting at 1. So be careful here how you set this up. You want to make sure you count from 0 to the length minus 1, rather than from 1 to the length. And then we'll iterate one at a time. So idx++ says add 1 each time through the loop. Okay, and what we do is we say, take the count in that reduced val object that we created and add to it whatever the count is for the current document. So it starts at 0, and each time we come across, for the math department for instance, each time we come across a math course, it says make the math count whatever it currently is plus the amount for the current course. And remember, each of those counts is 1 for the courses, so that's counting how many there are. And then for the enrollment, it does the same thing. It says take what we've found so far for math and add to it whatever this current math course has. And it'll do this, it knows to do this for each department separately. So it's going to create several of these reduced val objects, one for each department. So this is just looping through all the courses and adding up the enrollments and adding up the counts. And then once it does that for all of the documents, we return the result. So that's our second function. Okay, we do need a third function in this case because what we're interested in is an average, not a total. Right? So we want to know the average. Conveniently, we just returned both the total enrollment and the count of courses. So if you know the number of courses and you know the total enrollment, the average is really easy to calculate now that we've got that. And so this MapReduce structure, what it would do is it would run all of this on each individual cluster and then aggregate the results on the master machine when it reduces. And on that master machine, you would then have that final object that we just returned here called reduceVal. So what we're going to use here is a third function called a finalize function. And I'm calling it finalize2 because this is our second example. And this is going to take a key and a reduced val object. So in our case, the key will be the department name, and the reduced val object will be the object that was returned from the reduce function for that department. And what we're going to do is just say calculate a new value for that object called department average here. And that's going to be equal to the enrollment divided by the count. So this is the point at which we're able to calculate the actual average. So it aggregates the total enrollment and the number of classes from all the different clusters, combines that together using the reduce function, and at the end of that we get a total number of classes and a total enrollment for each department. This is where we can then, on that individual master machine, calculate the average. And so it does that for you, and then it returns the new object which has all of the original fields plus this new average field. So that's my third function. So a map function, a reduce function, and a finalize function. Okay, so now we need to call this so that it'll actually perform the aggregation. And what I'll do here again is db.enrollment.MapReduce, tell it which map function, so in this case map2, tell it which reduce function, so this will be reduce2, and then I need to tell it what to do about the output. And so here, that's where I specify the finalize function. So I'm going to put the results of this MapReduce into MapReduced2, that'll be the name of the collection, and the finalize function that I want to apply is finalize2. And if I run all of that, it'll tell me that it has, again, a total number of outputs of 4, so that's good, that's the number of departments. It tells me it ran. And now if I go and I take a look at the results from that, we see here we've got department average. So for biology, the average was 32.5 students per course. For chemistry, it's a little bit lower, 29.5. For math, it's really low, 21.25. And for physics, it's 24.25. Of course, when you get to your statistics class, the instructor for that course is going to be brutal and remind you that you have to watch out when you take averages. What kind of average is it? Is it a mean? Is it a median? Did you have outliers? Remember, the math department had one class with 0 students enrolled. So it looks like their classes are the smallest, but they probably had a class that was canceled, something like that, and their enrollments might not actually be the smallest on average. So you got to watch out for all those kinds of things. But this is not a stats class, so I'll just mention that and then leave it to you to learn about that stuff down the road. We could, of course, some of you are probably familiar, you might not like the way the output looks there. MongoDB does include an option here for the find function. You can do .pretty and create output that might be a little bit easier to read. In this case, it's not clear to me whether this is actually easier or not, but we do have such a small data set it probably doesn't matter. But just so you know that option is available. So you can append .pretty on the end of your find function. Okay. I will pause for questions and then I'll do one more example here to show you another MapReduce. Any questions? Awkward silence. Okay, let's move on. Do feel free to put questions in the window. Paul, that's a good question. I'm not sure the answer to that. I'd have to look it up, to be honest. But I'll look it up and I'll include it when I post these things. Can out be used for the aggregate? Yeah, I think rather than using out, what you would do is tell it to save the result that comes out into a new collection when you use the aggregate pipeline. So there's a way to aggregate, it creates a result, and then you can save that result. Sandy, I'm not sure. That might be a good question for Andy to talk about. I'm not familiar with exactly the details on massive parallel processing in databases enough.
MapReduce is really done in the software layer, and massive parallel processing is done in the hardware. So one is implemented at a lower level than the other.
Okay, great. Thank you.
I should say at the process level rather than at the application level.
Any other questions? Okay, let's take a look at one more example, just another average, just so you see another example of that. And what I'm going to do is calculate now what's the average enrollment by course rather than by department, just so you can see another example of that. Okay, so I'm going to create a third MapReduce function, and this will be very similar to the one that we just did. So again, I'm going to do a count and an enrollment, just like before, and the count will always be 1 because each document is a single class, and the enrollment is for the document that it's looking at, what is the value for the enrollment field, and then we'll emit the course number. So one example would be Math 101, right? Those are the course numbers. And then it'll emit that value combo, right? These two fields in that object. So that's my map function. It's might even be the same as the previous one exactly, except that we're calling it map3. The reduce function will be a little bit different. So here's the reduce function. Again, we're going to input a key and value combo, but now it's the course that's the key rather than the department. So here we're iterating across different courses rather than different departments. So we're going to have more results since each department has multiple courses. Values combo looks basically the same as it did before. It's got a count and it's got an enrollment, but now it's broken down by course rather than by department. Again, we'll start the counters at 0, right? And we're going to iterate through for each course number. We're going to iterate through all of the documents relevant to that course number, so all of the key value pairs for that course number. And we're going to again, just like before, take our current count and our current enrollment and add the new one to it, so that at the end of the process we've added them all together. And then we'll return that object. So this is very similar to before. The only difference is that we're iterating across courses rather than across departments, but the function is structured exactly the same. And here, the finalize function, just as a reminder, we're going to use the finalize function to actually calculate the average for each course. So just like before, I'm going to call the MapReduce function. And here we see output is 10, so that tells me we have 10 different courses in our data set. And let's take a look at those results. And so we see here you've got Biology 101, Biology 102, and then you've got 3 chemistry courses, 3 math courses, and 2 physics courses. And now for these courses, it's calculated the average enrollment. And so we can get a sense of what the enrollments look like. Okay, any questions at this point? Yeah, dot length says you've just passed me an array, and how long is it? And so when we use dot length up above here, the idea here is for the math department, for instance, there were 4 of them that had that department, and so the values combo dot length would be 4 because it's got 4 classes, 4 documents that come out of that. What else? Other questions? Oops. Okay, let's take a quick look then at the course quiz and assignment for the week, so that we can make sure you're all squared away and ready to go at those. So let me pull those up here. So the week 10 quiz, this is going to have you do some aggregation, and we've put the data set that you need. It comes from the MongoDB documentation site, so there's the link to that. Save that file to your machine and then use Mongo import to bring it in. You'll need to change your path name here. So there's the Windows version, here's the Unix version or Mac version. And then there are some good examples that are useful for you for this quiz on the aggregation help pages. So we've given you the link there as well. And then the questions here are just very simple. Which states have populations less than 8 million? So you'll need to aggregate at the state level for the population, and then just determine which ones are less than 8 million. And then which is the 5th largest city in New York? So you'll aggregate at the city level and sort those results. And then what's the total number of cities in each state based on this data set? So those are the 3 questions that we're asking you to do for this week's quiz. These are all expected to be done using the aggregation pipeline rather than MapReduce. So they should all be reasonably easy to do using the aggregation pipeline. If you're interested in taking it to the next level, Wikipedia, the world's most reliable source of information, has a list here of regions and districts. So, for instance, the Northeast region includes all of the states listed here in these 2 divisions, and then you'd say Division 1 or Division 2. So if you would like to, what you can do is update your data set that you've just created so that each observation now has the region and the division. And just so everybody's using the same information, we'll go with that Wikipedia page as our source. And so, in the challenge question here, update the data and then use it to answer very similar questions to what we asked up above, but now you're going to do things by region and by district rather than by city or state. So that part's not the particularly challenging part here. These questions, once you get the data updated, these questions should be reasonably straightforward. But the extra step here is to go ahead and write the code that updates the data. Stacy, that's a great question, and I don't want to answer it just yet. I want to let you guys do some research. But if you still have that question, discuss it in the forums. You guys are welcome to discuss it with each other. But there are probably, okay, Brett, I was about to say there are probably multiple ways to do it, and Brett seems to have 2 already. So I'm going to let you guys sort that out since it's an assignment. But do ask if you get stuck. But have a go at it for a while first. And then the quiz, that's the quiz. The assignment for the week is going to be where you do the MapReduce. And so we've given you just a single question to do here. Use the data set that's covered in the quiz. So that's the one we were just looking at. You can either delete the database out and then set it up from scratch again because you won't need the districts or regions, or you should be able just to work with it as is. So what we want you to do here is calculate the total population by state, but we want you to do it using MapReduce. And so if you take the examples we showed tonight and you tweak those to use the correct setup, then you should be in good shape. So I think that should be relatively straightforward. Stacy, if you'd like, I'm happy to set up a one-on-one session where we could take a look at it. I'm not trying to be rude and say I'm not going to help you. I do want everybody else to have a chance to research it if they haven't first. So shoot me an email and we can set up a one-on-one session, or you can discuss it in the forums. It's really up to you. But I want everybody, so it's not about any one person. I want everybody to have a chance to try that. Okay, any questions before we wrap it up here? Okay, everybody has their preferred environments. MongoDB has pretty tough syntax, so I can't imagine that it's going to be anybody's particularly favorite environment. But it is a good first NoSQL solution to take a look at. I think most of it is relatively straightforward. I've told some people in the lab sessions that we did this week that if you really like MongoDB and you want to work with it even more, probably your next step is going to be to get a little bit more familiar with JavaScript so that you're a little bit more comfortable writing commands for MongoDB. There are several people who have recommended some visual solutions. I think Andy had somebody in his class, I think it was, I'm going to just call a name out, Eric, I think recommended Eric recommended an editor, a visual editor. Andy, could you type that in the chat window so everybody can see it, just what it was called? RoboMongo? Thanks, Eric. So you might want to explore that as well. I do everything at the command line, so I've been just working in the terminal. I do use things like Notepad or just a simple text file to store my code. But if you prefer a visual environment, then give RoboMongo a try. MongoDB is open source and currently under heavy development, right? It's relatively new, so things are constantly changing. Get comfortable with the documentation pages. I find them really, really useful. Maybe that's just me, but I do find them really useful. So those would be next steps with MongoDB. Learn a little bit more about JavaScript, learn a little bit more about some of the different environments you can use to work with MongoDB. If you like R, learn about how to work with it with R, and so on. Parshu, I copied and pasted to the command line in Mongo for the last 45 minutes, so it should work. If you're having trouble, just get a hold of us and ask us, and we can probably help you sort that out. But that's what I've been doing all night. So, any other questions? Okay, well, reach out as you do have questions. You can use the discussion forums or email, or we can set up sessions. And as I said, I'll post the code that I used tonight, and I'll post the data set. And we've also been recording this, so we'll post the session as well. And so if nobody has anything else, I think I'll wrap it up and end the meeting here in just a minute. Okay, everybody have a good weekend, and let us know as you have questions, and we'll see you in... oh, no, let me remind you, just in 2 weeks, there is a guest lecture at 8 o'clock. We'll send out more information about that before then. That'll be more important for Andy's class, because you guys, that's going to be right at the same time as your meetup. So Andy will tell you all the details of that. For my class, we'll still have our regular meetup first, and then there will be a guest lecture at 8 o'clock. You are expected to attend both, but as always, we're going to post recordings, so that if schedule-wise that doesn't work, you should be able to watch them later. So look for more details about that. And otherwise, get to it and enjoy this work. I've really been liking MongoDB, so have fun.
Thanks, Mike.
Great stuff, Mike. Thanks.